Let's start then. So good morning, good afternoon, and good evening for everyone at the second day of the ANSO workshop on women in science towards the diversity of research and researcher. Yesterday, we discussed policy considerations and actions that help promote women's career in science. And today, we are going to hear some presentations of actual science by women scientists who are themselves at the forefront of scientific research. Today's session will be chaired by Professor Enikő Bolobás, Chair of the Presidential Committee of Women in Science at the Hungarian Academy of Sciences, also a member of the Hungarian Academy of Sciences and a scholar of literature. May I now ask Professor Bolobás to take over and chair the session.
Thank you very much, Dr. Böhm. It's my very great pleasure to chair today's series of lectures. We are going to have a whole range of sciences, disciplines represented here today. Atmospheric physics, computer sciences, astrophysics, physics and chemistry, metal processing, finance and administration, biology, neurobiology, spectroscopy. What an intellectual smorgasbord we have today. We will have also the task, and we shouldn't forget about that, to decide on the final document, our recommendations after all these exciting lectures. But without further ado, I would like to invite our first speaker, Kie-Xiu Xu, professor at the Institute of Atmospheric Physics at the Chinese Academy of Sciences. Professor Kie, please.
Thank you, Mr. Chairman. Thanks for this invitation. I'm Xiu Kie from Institute of Atmospheric Physics, Chinese Academy of Sciences. I'm also the president of the International Commission on Atmospheric Electricity. It's my great honor to take this opportunity to share some of my research with our women colleagues here from the globe. I think this is a wonderful moment. Okay, the title of my talk is Lightning and Artificial Modification. Here is my outline of my talk. First, I will give a very brief introduction on lightning phenomena. Then I will show you the global distribution and the trends of lightning activity. Finally, I will show lightning artificial modification and to see how can lightning be artificially triggered or controlled. These beautiful pictures shows the diversity and the randomness of lightning discharges. Usually, lightning can be defined as a transient long-distance discharge phenomena in the atmosphere, but with a large peak current, high voltage, and a severe electromagnetic field. The lightning usually can be divided into two types, cloud to ground lightning, which takes about 1/3 of all lightning. The second one is intracloud lightning, takes about 2/3. It occurred inside the cloud or between two clouds. Although these light pictures are very beautiful, but as a matter of fact, lightning has caused a large number of casualties and considerable economic losses worldwide. The most lightning killer is in North India because of India and there are many lightning activities there and many farmers and many outdoor workers. In addition to the death of livestock and human beings, it also can cause power failure, interface communication, damage of wind farm. Lightning is also a threat to aerospace. It can strike rocket launch pad and even spacecraft during its flight after launch. So how to mitigate lightning disasters or how to protect facilities from lightning? There are many challenges. This video shows how lightning propagates to ground from cloud. We call these processes as a stepped leader. It is captured by a high-speed video camera operating at a speed of 10,000 frames per second. We can see this processes propagate in a very fast speed of 10 to 5 meters per second. But after this process, or following this, is even powerful return stroke processes with a speed of 10 to 8 meters per second. The peak current of the stroke, the return stroke, can be from 40 to more than 200 kiloampere. And the temperature inside the discharge channel can reach to 30,000 degrees centigrade. Although each lightning discharge lasts just shorter than 1 second, it can propagate over tens to hundreds kilometers and consists of several sub-discharge processes. The main processes can be step leader like here, and return stroke, dart leader, and so on. Most of these sub-processes just last in microseconds or milliseconds. So it's a very challenging to detect them. So far, we can measure some lightning, but before we can actively protect property against the lightning, it is very important to know where is the lightning occurred more frequently. How does lightning initiate it? What is the mechanism of lightning hazard? And how to protect the lightning effectively. So far, lightning can be detected or located based on space or satellite or at the ground. If we detect the lightning at the ground, we can set up a network and receive electromagnetic field emitted from lightning. Then we locate the lightning or in global scale or regional scale or local scale. This picture shows the global lightning distribution observed from space. We can see clearly that lightning occurs mainly over land areas with an average land to ocean ratio of about 10 to 1. Very few lightning over the ocean. The mean global flash rate is 46 flashes per second. And the maximum of lightning density you can see here is in the Eastern Congo with an annual flash rate of 160 flash per kilometers per year. And in addition, there are some other lightning spots, say in South America, in South Asia, and also north part of India, the south part of south slope of the Himalayas. So this is the reason why the lightning killer in India is so high. These figures show the lightning trends in the South Asia region in the last 20 years. We can see there is a clear increase trend with an increase rate of 0.018 flash per kilometers per year. This may indicate lightning killer will be increasing if we do not adopt action in this region. For the natural lightning, it occurs somehow randomly, so it is not easy to measure it directly. How can we know its nature and its intensity to design an effective lightning protection devices? Is the lightning can be controlled? Yes, now we can do it. These pictures show triggering lightning experiment site in Shandong province, which is located in southeast of Beijing, about 3 kilometers away from Beijing. And this is our designed rocket with the trailing wire here. So under some favorable condition, thunderstorm conditions, we can fire the rocket toward the thunderstorm. Then the lightning can be triggered, and the lightning will strike at this lightning rod. Then inside this Faraday cage, we can measure the lightning current with this current sensor. And we also can measure the close electromagnetic field in the near the lightning channel. And also we can measure all the radiation field from the lightning. So this is a very powerful platform to measure lightning. This triggered lightning, I would say, provide the best simulation of natural lightning with known location and time. And we can use to lightning research and testing on protection technology. Like this one is a communication tower. We can test the lightning protection on this communication tower. Okay, I will show you what's the lightning, how the lightning triggered. You can see this beautiful video here clearly show how lightning is triggered. The lightning, first this is the lightning channel, and this is the rocket with a trailing wire. Then we can trigger the lightning into the lightning rod here. So it's really wonderful. There's 2 pictures. You can see this all the triggered lightning captured at 60 meters away from the lightning and about 550 meters away from the lightning channel. Now, by using this triggered lightning, we can measure many parameters of lightning discharge, say peak current, close electromagnetic field, and so on. We can use this triggering technique for both basic research and lightning protection study. So this triggered lightning makes our dream of controlling lightning become true partially. This is the lightning current waveform we measured during the triggered lightning. You can see that the peak of the lightning can be small, say 600 kiloampere, 6 kiloampere, or 45 kiloampere. This is the peak here. But the rest time is very fast. That means the radiation electric field could be very strong and powerful and harmful to our electronic devices. To detect lightning or measure the lightning, we have developed a series of state-of-the-art lightning detection devices. Here I just show one of them. We call it the VHF lightning interferometry mapping system. This is our outdoor lightning signal receiving antenna array, usually it's 4. And this is the data processor. And this is some specification. I'm sorry, it is in Chinese, but it doesn't matter. You need not to understand them in detail. Okay, this is I really would like to show you. This is the VHF lightning interferometer can depict lightning discharge in a time resolution of 1 microsecond. This animation clearly shows the lightning development from the cloud. This is in the cloud region. There are 2 regions with the high peak radiation sources here. This is the radiation or the discharge flow from the cloud to the ground. And we can see the leader processes can be reached from 10 to 5 to 10 to 7 meters per second. So with this interferometer, we have reviewed many lightning new natures, but because of the time, I will not show you the detail, but just you can compare here. From the optical image, we just can see a very short view, but based on this VHF interferometer, we can see the lightning discharge inside the cloud. So it can reveal how lightning can be initiated in the cloud and how lightning propagated inside the cloud. So this is a wonderful instrument for us. So here comes the summary. Lightning is one of the major meteorologic disasters, especially in South Asia. Many injuries and losses are reported each year. Asia is a hotspot region of lightning activity, and it increases significantly in the recent 20 years in South Asia. In addition of Congo, the trend of lightning is not so clearly. It is necessary and possible to build a regional lightning detection network among Asia countries, especially South Asia. Lightning can be artificially triggered by launching a special designed wire trailing rocket toward an electrified thunderstorm, providing an effective way to control or mitigate lightning disasters. And also it can validate lightning detection and protection technologies. This is all I would like to show you. Thank you.
Thank you very much, Professor Key. This was a most exciting presentation, and I always appreciate such presentations where people outside your field understand it too. I come from the humanities and I could perfectly follow you, and I have so much, I'm so grateful for those spectacular images that you added light, extra light to your presentation, and how very far we have come from when in the late 18th century, Benjamin Franklin invented the lightning rod.
Yeah, yes, yeah.
Okay.
Yeah, thank you.
Wonderful. I will ask you later during our discussion session why lightning activity has increased in the past 20 years in Asia. If we can leave that question for later.
Okay, thank you.
Thank you very much.
Thank you. Bye-bye.
Thank you. It is my very great pleasure to invite Professor Chao Mgbogo, founder and program lead at Kami Limu, Dean of the School of Science and Technology at Kenya Methodist University. We have our very impressive CV here, your very impressive CV. It's always a very great pleasure to have a woman, to see a woman in computer sciences. Please, Professor Mgbogo, you requested that we change the order of the speakers.
So I will go next, yes.
Next, that is after our next speaker. Okay, thank you very much. Okay, we'll come back to you and let us know if you're ready.
And then I'll go next.
Yes, so okay, after our next speaker.
My connection.
Okay, very good. This time,
Yes.
I will invite Dr. Agnes Koshbar from Hungary, who is research advisor at the Concoy Observatory, Research Center for Astronomy and Earth Sciences in Hungary, and a researcher in astrophysics. And her lecture is entitled The Infancy of Sun-like Stars. Dr. Koshbar, are you here?
Thank you very much. So first, I would like to thank the organizers for inviting me to give this talk. So my name is Agnes Koshbar. I'm based at Concoy Observatory in Budapest, Hungary, where I'm working together with many excellent colleagues with support from the European Research Council and from the Hungarian Academy of Sciences. Today, I'm going to talk about the infancy of sun-like stars. So if you go away from the urban light pollution to the countryside or perhaps to a high mountain and you look up at the sky during a dark and clear night, you will be able to see the bright band of the Milky Way. If you have good eyes, you may notice that there are darker spots in the Milky Way. These are very interesting because these mark the locations of dense clouds of interstellar gas and dust where there's ongoing star formation, where new stars are being born. Why do we care about this? Well, many of you may recognize this image. This is our sun. Don't be alarmed by the spots. Those are completely regular sunspots, natural byproducts of the solar activity. But the sun has not always looked like this. When our sun was young, it looked like this. This is an artistic rendition of how a young star called EX Lupi in the Lupus constellation, about 500 light years from us, may look like. I study EX Lupi and other stars like this because I want to understand how stars like our sun and planets like our Earth formed. The sun is about 4.5 billion years old, but EX Lupi was born only a few million years ago. We consider it the little sibling of the sun. It is so young that it is still gathering material from its surroundings. Such newborn stars are surrounded by a disk of gas and dust, and material flows from the disk onto the star. This is how the star is being built up, and the disks are also the birthplaces of planets. Previously, astronomers thought that disks are simple symmetric structures, and the flow of material from the disk to the star is also a smooth and steady process. Now we know that this is not true. With the most high-tech instrumentation, we can now make direct images of the disks around young stars, as you can see here in this example. This is the disk around the young star called HL Tauri in the Taurus constellation, again about 500 light years from us. You can see that there are denser, brighter rings in the disk, and there are also more tenuous, darker gaps. And this is not a unique system. Now we know that most disks look like this. Look at this nice collection of images of protoplanetary disks around young stars. These are all solar systems in the making, although they may form planetary systems that are somewhat different from our sun and from our solar system. This image compares the size of the protoplanetary disk around HL Tauri with the solar system. Although the star here is much smaller than the sun, the disk around HL Tauri stretches out to almost 3 times as far from the star as Neptune from the sun. Using spectroscopy, we can now study the structure and composition of the material that makes up the disk. The farther away, colder parts typically contain ice-coated dust grains, while the warmer innermost parts are made of bare dust grains and molecules. This is important so that we can understand where in the disk can we form, for example, icy comets or gas giants, or rocky planets like Mars or Earth. But how do we make such sharp images with full of tiny details? Well, we use instruments like ALMA, the Atacama Large Millimeter Submillimeter Array, or the James Webb Space Telescope. ALMA is a radio antenna array in Chile an interferometer where the radio signal from the young stars is detected by several antennas that work together as a giant telescope. The Webb is an infrared space telescope that will travel 150 million kilometers away from Earth. Both instruments use light that is invisible to our own eyes. The radio or infrared radiation is needed to peer through the intervening dust clouds that would otherwise hide the disks that we want to study. Most of this radiation, infrared and radio, is absorbed by the Earth's atmosphere, in particular its water vapor content. So that's why we have to construct our telescopes at very high altitudes, where the air is very thin and dry, or launch our telescopes to space well above Earth's atmosphere. With my collaborators, we study many young stars with ALMA. One of our targets is in the Taurus constellation, not very far from HL Tauri actually, and it's called L1515 Iris 5. It is a binary star, two stars separated by a distance which is about 50 times the distance between Earth and the Sun. With ALMA, we detected the signature of many, many different molecules in the disk that surrounds these two stars. These images show the spatial distribution of these molecules. We detected smelly molecules like sulfur dioxide and hydrogen sulfide, toxic molecules like methanol and ethanol, and even some complex organic molecules like methylformate or glycolaldehyde, the simplest sugar-related molecule. It is exciting to imagine that if planets are forming in these disks, then these molecules may be incorporated into their atmospheres. Whether they will be habitable and whether life can form on their surfaces is another question. But considering advances in the characterization of exoplanet atmospheres, the studying of this question may not stay in the realm of science fiction for much longer. I mentioned earlier that the transport of material from the disk onto the star is not steady. Sometimes it becomes much stronger and faster for a while. These events are called outbursts because they cause the star and the disk to become much hotter and brighter. We observed one such event, such outburst, in the young star EX Lupi, which suddenly became 100 times brighter in 2008 for about half a year, and then it went back to quiescence. We took an infrared spectrum of EX Lupi during its outburst, and we used the Spitzer Space Telescope for this. What we saw in this new spectrum is that the spectral features became, they changed significantly compared to what it looked like before the outburst. This change occurred because the previously amorphous silicate crystals in the disk turned into crystalline forced-ride grains due to the heat of the outburst. This change from amorphous to crystalline only happens if you heat up the dust grains to 1000 Kelvin or 700 degrees Celsius. Why do we care about the silicate crystals? Because they are essential ingredients if you want to make comets. We know that the comets in the solar system contain a dust that has a very high crystalline diffraction, that is a lot of forced-ride. But no one really understood how it is possible that comets that come from the cold, faraway regions of our solar system can contain material that formed at high temperatures. The example of EX Lupi demonstrates that maybe the outbursts of young stars provide an explanation for this. At least we know that crystals can form during an outburst. It is still an open question whether they can survive long enough to be incorporated into comets. And for that, they also need to be transported from the warmer disk regions where they formed to the colder disk regions where they can be part of comets. Unfortunately, cold crystals have very, very weak infrared signal, and currently there is no instrument sensitive enough to detect them. But that will soon change. In about a month, specifically on the 18th of December this year, the European Space Agency will launch the James Webb Space Telescope. And once it starts observing, one of its targets will be EX Lupi. We proposed this observation in a proposal which was successful, accepted. So the telescope will make these observations for us hopefully early next year. So we may soon understand the mystery of the comet crystals by studying the disks of faraway infant stars. For me, it is absolutely fascinating that by studying star formation, we can indirectly understand better the past of our sun and Earth, which is one of humankind's earliest questions. So stay tuned for exciting new results. Finally, I would like to thank my group members and collaborators who used to work or who are currently working with me at Konkoly Observatory. They make this work all worthwhile. Thank you very much.
This was a mind-boggling presentation, mind-expanding presentation. We have to, at least certainly coming from other disciplines very far away, I have to expand my understanding, my comprehension. But still, you are talking about incomprehensible distances. And this was a very witty and illuminating presentation. Thank you very much. So there will be a time when there will be more than one sun for the inhabitants of the Earth?
For Earth, probably not, but for other exoplanets and other distant stars, surely, yes.
Okay. Wow. Okay. You should go into science fiction film too. Yes. They should be extremely grateful to have you there. Thank you very much. Professor Chao, can I ask you if you can join us now? No, probably not. We don't see Professor Chao among the participants, do we? No. No. Okay. Well, your slot is open. Whenever you can join us, you are very welcome. Please let us know if you hear us. Thank you very much. Our next speaker is Professor Gao Bo, Deputy Director of the TIPC LNE Joint Laboratory on Cryptogenic Metrology Sciences and Technology at the Technical Institute of Physics and Chemistry of the Chinese Academy of Sciences. We are moving on then to physics and chemistry, and Professor Gao's presentation is entitled Progress on Thermodynamic Temperature Measurements from 5K to 24.5K under new definition of Kelvin. Professor Gao.
Hello, everyone. I'm Gao Bo, come from Technical Institute of Physics and Chemistry, Chinese Academy of Science. It's my great honor to share my research in here because the last topic is really hard to understand. I changed a new one, sorry. My topic is low temperature measurement under new definition of international system of units. My talk is divided into 3 parts. Now let me introduce the background. Maybe you will ask me, what is the low temperature range? Usually, they mentioned is below 120 Kelvin. Actually, our team focus on even lower. We focus on the temperature below 24.5561 Kelvin. In this temperature range, high accuracy temperature measurement is very important. And such as for the frontier science, everybody knows the LHC in Europe. When the colleagues in Europe built the LHC, they spent 5 years to calibrate more than 6,000 of high accuracy thermometers around 27 kilometers. According to our estimation, there are more than 50% of large scientific facilities work in this low temperature range. And in some other parts of a new energy resource and space science, the key point should work in the high accuracy temperature range in this temperature range. So since this temperature range is very important, how to guarantee to get high accuracy measurement. Actually, they relies on the traceable system. In one country, a traceable system should be divided 3 levels according to the accuracy. The top is the primary system. Unfortunately, in history, we never set up any primary system below 24.5 Kelvin in China. So the second level, which means the standard thermometer, should be sent to the country that have been built the primary systems and from time to time and get the calibration, which is not convenience. So we should build our own primary thermometry below 24.5 Kelvin. There is another function of primary thermometry. Because they can output the thermodynamic temperature, which is the basis for making or revising international temperature scale. From this picture, you can see we never contribute to revise any international temperature scale below 24.5 Kelvin since 1927. There is a new chance and a new revolutionary in meteorology research field, give us not only China, but also world a new chance. In 2090, the 7 basic units for SI are redefined by the fundamental constant instead of artifact. For this redefinition, William Phillips gives comments like this: our metric system is experiencing its greatest revolution since the French Revolution. This is a significant opportunity for the human being. Under this new ISI, the thermodynamic temperature units, Kelvin, is redefined by Boltzmann constant, which means under this new ISI, any country can build their primary thermometries in any temperature range linked to the Boltzmann constant directly. So this is a good opportunity for us to build the primary thermometry below 24.5 Kelvin. How to build? There list 3 modern primary thermometry methods, but unfortunately, all these 3 is hard to implement in China in short time. We should find a new way to implement primary thermometry. We put forward a new method we named single pressure refractive index gas thermometry. We call SPRIT. In theory, the SPRIT potential uncertainty is better than the 3 existing methods. Now let me introduce the research progress. In order to realize our new idea, we built a joint lab on cryogenic metrology science and the technologies between China and French. And we built an international team. We start from 0, from an empty room and an empty lab. This is my twin daughter. And in the Langfang city, we are far away from the Beijing. After 3 years, we make progress. In this picture, we can see to realize SPRIT, we need to develop 3 key technologies, and we built 3 subsystems: a temperature regulation system and a pressure control system. And after we get these 2 boundary conditions, we can realize get the high accuracy measurement of frequency in this part. In order to get a high stable temperature regulation, we do lots of work, such as we predict the theoretical stability limit, and we design new structure, and we develop the software, and we build a high stability system. Finally, we propose the limit of stability. The temperature stability is better than 50 microkelvin in 5 to 24.5 Kelvin. To get the high stable temperature pressure control, we developed the microflow compensation pressure control method, built ultra stable system, and we realized the pressure relative stability better than 0.16 ppm from 30 to 120,000 Pascal. Finally, we realized in order to get the high accuracy frequency measurement, we propose a relative exercise half-wide closed method and a hybrid frequency sweep mode, developed a new system and get relative uncertainty of resonance frequency better than 31 ppt. After we get these three subsystems, we coupled with and became the spread. Our spread is the first primary thermometry from the 5 Kelvin to 24.5 Kelvin under the new ISI, and we get the best thermal temperature result in the world by now. And our data have been used to revise the international temperature scale by CCT. Now, next, our plan for the future work. In the next few years, we will build the primary thermometry in the hollow temperature range. Another point, the new ISI has opened a new door for the new international cooperation. We would like to call on an international cooperation under the new ISI and preparing for the new international temperature scale. It will promote the implementation of new ISI and benefit our world. Thank you for the listening. Thanks.
Thank you very much. This was, again, a very hugely interesting and mind-expanding lecture, especially because you were talking about changing certain central structures in the way we see the world and the way scientists see their objects. I am sure this will bring about tremendous changes in research. Thank you very much.
Thank you very much.
I am calling Professor Chow now, who seems...
Yes, I am ready.
Yeah.
Can you hear me now well?
Yes, very well.
Wonderful. Thank you so much.
What a joy.
Thank you. I had to move my venue, so that has helped.
Good.
Thanks.
Oh, we are grateful, very grateful you moved.
So thank you so much for your patience. So I wanted to approach my presentation from a slightly different angle and talk about something I've become really passionate about over the last 5 years and the lessons from that, which is how becoming an active mentor made me a better researcher. And I will do that by focusing on 3 areas in my presentation. I'll touch a bit on what my research work is, what my mentorship work is, and the lessons that converge those two that have been a source of reflection for me in understanding how that has made me and continues to make me a better researcher. So starting out with my research work. So my research work really stems in understanding when we have students who may not have access to resources such as mobile phones or laptops, and that can be from completely not having access to those resources at home to having few students or rather few resources in schools and many students in the same school, so the resource sharing is not very good. and understanding how can we use the devices that they have, which is mobile phones, because up to over 90% of students in higher institutions of learning have mobile phones. How can you use those mobile devices to help them learn a practical subject such as computer programming? And so I approached the question of how can we derive scaffolding? So scaffolding is exactly from the word of the scaffolds around buildings. So supporting techniques that will support Java programming on a mobile phone. And I specifically focused on Java because it is one of the languages with a higher learning curve and one that a lot of new students find most challenging. And how can we support learners to use the devices that they have to be able to learn such a practical subject, which is best learned by doing? And this was the fundamental question that led me to then building and designing a mobile application. This is just a very small part of the interface where we were looking at, if you have such limited devices, how are you able to design for them, taking care of the fact that they have small screens, they were not built to be programming environments. How do you design such an interface to enable someone to practically create a program? And just to give an overview of what you're seeing on the screen, if you've played any computer game, then it is likely that you probably started from level 1 and then level 2 is not unlocked until level 1 is locked. So that is actually a scaffolding technique where you're forced to learn a fundamental concept before the next stage is unlocked. So that is an example of a scaffolding technique that we then brought onto the mobile phone, where we are creating a program, a small part at a time. And educational theory has shown that if a student can be able to learn one small thing before proceeding to the bigger thing, then they're able to learn better. So that is one example of the many techniques that was used to design for programming on the mobile phone. And this led to an application that students could use. So this on the screen is in fact students who are trying out the mobile application during the experiments, and they were given, so we had a controlled experiment where we had students who were using this specifically designed application and some who are not using the specifically designed application still on the mobile phone to tackle the same programming assignments. And I experimented with students from 4 universities, 2 in South Africa and 2 in Kenya. And the result was very interesting, but generally, one of the things we are trying to figure out is which scaffolding techniques are actually effective in enabling our students to use such limited devices to actually program on the mobile phone. And the overall result is that when we have limited devices, such as mobile phone, you can actually specifically design for them and using learners' needs, understanding how learners actually program. If it's mathematics, then it will be understanding how learners actually do maths. And you can be able to build specifically designed techniques to enable students, especially those from resource-constrained environments, to still learn computer programming or maths or any other practical subjects using their mobile phones. So this is a very brief overview of the research work. Now let me bring in the other aspect of my work, which is mentorship. So the need for the mentorship came about when we did a study and we found out that up to 80% of Kenyan university students do not receive mentorship outside the classroom. Now, why is this important? It's important because the way our curriculum is designed, we don't teach all the skills that are needed for global competitiveness. And yet there's study after study that has shown that employers associate the high number of unemployed graduates with the quality of training they receive. So the hypothesis is that if we are able to complement what the students learn in the classroom with some mentorship of sort, irrespective of the model, then we can be able to create more whole-rounded graduates or more whole-rounded students. So this need then led to the design of a structured mentorship that complements classroom learning for tech students, which is my area, so for tech and engineering students. And it focuses on 5 pillars. These pillars were designed from understanding users' needs, from doing a survey to understand what are the skills that are not quite explored in the classroom, but are extremely crucial, especially when you talk about 21st century skills for tech students to really thrive both locally and internationally. And we have 5 of those skills that are explored in this model from innovation. So for example, students learn technical skills in the classroom, but they're not necessarily taught how to use those technical skills to solve socioeconomic problems, which is where innovation comes in. To professional development, which explore questions like, how do I prepare for a technical interview? To personal development, which explore questions like, how do I present my technical results or my technical research to a mixed audience? To community involvement, which explore questions like, how do I immerse myself in the local and technical and international community in order to really expand my technical skills? And lastly, how do I apply for grants, for innovation, seed funding, or whatever level of funding to be able to build my innovation that has come out from the skills I learned in the classroom? And these 5 areas then led to the foundation of a social enterprise that is called Kamilimu, and that embodies the structured mentorship model on which these 5 pillars are built, and I'm the founder and program lead for that. Now, if we just quickly look at the impact of that for tech students over the last 5 years, we've managed to complement classroom learning for students from up to 24 universities in the country. And this demand has seen, we've increased from applications from students from just 4 universities in 2016 to 38 universities in 2021. And because it's an 8-month mentorship program, we've been able to work now with 204 students from 24 institutions. And throughout the time, we measure impact, and up to 95% of the beneficiaries are able to nurture their employability skills. And in so doing, we've had 9 employers who've hired talent directly from the mentorship program. And last year, we were very privileged to win 2 international awards that recognize the impact on employability as well as learning outcomes. So how do those 2 converge? So over the last 5 years, when I've been actively doing the out of the classroom mentorship for engineering and tech students, and also still doing my research, I realized that there has been a really beautiful convergence in my own skills, in the skills of the students I work with, and in the community that I serve. So I'm going to share 5 ways that being a mentor, or becoming an active mentor, has made me a better researcher, and hopefully that will continue enabling me to produce good research that informs computer science. So the first is better innovation. So over the last 2 years, I have been working with a lot of engineers in the UX, UI, or user interface design community. And they've really helped me to rethink about how to redesign the prototype for supporting students to learn computer programming using modern tools. And this came about because in the mentorship program, we focus on innovation. And innovation here, because I'm a computer scientist by training, but I really had to immerse myself in very innovative concepts in order to realize that the application that I initially built to support students to learn programming can actually be much better, much more effective, and even much more beautiful. And this has really led to very beautiful insights. And this is an example of one of the brainstorming sessions for understanding how we can move the prototype from the first version to something more useful and that can serve students even much better. The second aspect is how using the research skills, I've been able to contribute to mentorship frameworks, especially in tech, where that was not very popular. So for example, these are 2 screenshots of 2 papers that emerged from writing and analyzing and understanding the impact of mentorship on employability, the impact of mentorship on learning outcomes, and both were published in very highly peer-reviewed platforms and a conference. And it was really amazing for me how I was able to take my research skills that I learned throughout my profession, even in the PhD, to really curate an experiment and being immersed in the mentorship field itself. So it is more or less a longitudinal study to really understand how I'm able to measure the impact and what metrics to use to measure impact of mentorship on students, especially those in tech and outside the classroom. So this way, I've been able to start contributing to the conversation around how do we think about mentorship frameworks, especially for tech and engineering students, without taking them away from the classroom. And third, it has also enabled me to expand research outside the classroom. And for example, I just took a screenshot of a video of, these were the country winners from the Red Bull Basement 2020 innovation competition. And these were my students who came from the mentorship program, and using both research and innovation skills, we were able to design an application that captures culture. So it's actually called Capture Culture, because we found that a lot of the culture, indigenous culture that we have, is getting eroded, and we explored ways of using digitization and technology to preserve that culture, especially for young people. And this enabled this team, or these two students, to not only emerge as the country winners in this international competition, but it has now led to a startup that they're exploring to build into a fully blown business. So this is an example of taking research skills and mentorship skills and combining them, and really expanding research to have its impact outside the confines of the classroom or the confines of a university. And then the most beautiful thing for me personally is that having explored or continuing exploring both areas of research and mentorship has done a really, really amazing job in equipping my own soft technical skills. So notice that I'm not calling them soft skills, I'm calling them soft technical skills, because they're becoming increasingly crucial in our work as researchers, our work as educators, and so we can't separate soft from technical skills any longer. So for example, I've been really taught and continue learning how to communicate my science. So incidentally, because OWSD is one of the sponsors of this workshop, this picture was taken at the OWSD award ceremony early last year. And that experience has been very instrumental in ensuring that I can communicate my science to a mixed audience and continue passing that training on to students as well. And early this year, I used the same skills to be able to contribute into a TED Talk, which you can watch at your own time. And this the skills of being both a researcher and a mentor has put me in quite a unique perspective of combining both skills and being able to really, really communicate my science, however complex it is, to any audience anywhere. And lastly, just like all beautiful work can't be done in isolation. So the expanse of networks and communities that I've been able to interact with and serve has really continually built my own skills and the skills of the students that I serve in enriching and expanding the community and networks that I have access to, which ultimately makes me a better scientist. So thank you very much.
Convincing presentation. It's very imaginative. It's very interesting how you show research and mentoring as in dialogue with each other, and how you have convinced us too that mentoring is has a feedback effect upon your own research. Wonderful. And I like your metaphors a lot.
Thank you very
Scaffolding
much.
And soft skills and so on. And I think that's part of the vocabulary which helps bring together your scientific results to everyone else, to your audiences and your students. Thank you very much. Our next speaker, Professor Anjali Immanungun, Principal Researcher at the National Metal and Materials Technology Center, National Science and Technology Development Agency in Thailand. Professor Immanungun's talk is about powder metallurgy research from lab to mass production. Professor Immanungun.
Yep, thank you. Can you allow me to share, please?
Yes, yes, we can see you and hear you very well.
Yep, good morning, good evening, good afternoon, everyone. So my name is Anjali Immanungun. Yeah, I'm from Thailand. So our center is a National Center for Materials and Metals. Okay, we are a member of NASA. Okay, so it's an honor that you invite me to share my work here. So I am a material scientist or material engineer. So the work we done in MTech in NASA is we are trying to bridge a gap between university and the industry. So things that we do is trying to implement things in companies, in industry, so that our research work is being used in real production. Okay, so I will briefly introduce our lab. Our lab is, we call the MIM lab, so it's metal injection molding. And then we will give some example of industrial-based research work. Actually, I have been working in MTech for the past 22 years, so we have many examples. So we will pick something that would be interesting for you. It's interesting to me, so hopefully it's interesting for you as well. And the last thing we want to talk about is our exciting current work that we do. So our lab is actually metal injection molding, or MIM. So what we do is literally we do injection molding of metal parts. Okay, so if you imagine that you people might understand the injection molding of the plastic part, then you melt the polymer and then you inject it into shape in the solid mold. Instead, you can do ceramics material and you can do metals as well. Okay. So what we do is the part that we do is things that, this is example of things that commercially produced in the market at the moment in all your mobile phone, your watches, and everything that have little metal parts, they have the MIM parts that being produced by this technology. Okay, so our lab is literally started in 2003 when we received the funding from NATO Japan. So they give us a €1 million sponsorship so that we have, in over one night, we have the whole lab set up. So literally the whole, every equipment is being transported from Japan to Thailand. And then we have the basic technology and then we develop the technology. So, and the project itself from the Japan side is actually supported by both companies, for example, Osaka Yakin and like Admix and other companies. And we also have university from Japan that helping us with the starting technology. And we're working with university in Thailand to develop the technology. So this is the equipment that come overnight. And then we are fully equipped lab in Thailand. Now from that equipment, 40 million baht, for €1 million, what we do with that is what is more interesting. So we're starting with learning a technology. The Japanese government, the Japanese partner is really kind to us and allow some of myself and some of my assistant and my student to be to train in Japan. And so we can start really quickly. So the example of what we do, we're working with a company called SUS, and our technology is being done in the lab, and then it's being implemented in the company. Now, what is interesting is the company itself is doing the process we call the sintering process. At the beginning, they were using 1 atmosphere, and then in the lab we do several experiments, and then we found that if they change the way of sintering it, they can increase the corrosion resistance of the parts. So this project is actually relatively short for us, so it's about 3 months. But because it's the Japanese company in Thailand, to change their production process is very difficult, because normally company in Thailand, they do all the production according to the parents companies abroad. So the process of asking the parent company in Japan to allow us to change the process in the company in Thailand is taking 6 months. So after this being done, then currently the company is actually mass producing this and send all their parts around the world. So last year, the past year, they actually have sale like more than 20 million euro. Okay, that is a profit. Okay, the other company is called Castem. Castem actually a metal injection molding company in Japan. They are one of the companies that train us with the technology. But at that time in 2004, they couldn't do they cannot do titanium. They can only do steel, stainless steel. So what we do is we do the experimental testing in our lab, trying different processing conditions, doing this prototype, so that we have good repeatability of the parts that produce in the lab and the good processing condition. Then we transfer all this processing technology to Castem Thailand, and so this is the one that we can do in the lab. What is the most important one is the length. This length is end at about 18%. That is the elongation, how it's be able to stretch out after we do the tensile testing, the pooling. Okay. We implement the process in Castem Thailand, and what happened is we think they do exactly what we told them, teach them to do. And this is what happened after we do the sintering production in the company. The strain, the elongation is reduced to 4%. And this is typical when we form the lab. Everything is being controlled, things in the lab being done by master, PhD people. And when we transfer everything to company, yeah, they have like day-to-day workers. They didn't do things as careful as we did in the lab. Then it caused problem during the mass production. So we have to go into the company and trying to sort out what happened, investigate what went wrong in that production process that we have been transferred to them. And after solving the problem, and the problem is really little, is a contamination within the process itself, but looking for the contamination part is quite difficult. So after we solving all the problem, then the company can produce the part exactly like we did in the lab. So now the company is being mass producing titanium during the MIM process. And at that time in 2006, Castem became the second company in Asia that can do this. And this is another example. We work with another company called Taisei Thailand. They asked us to do this titanium foam, which is a new processing. And this is really interesting for us because it's a really long story for us. We starting with we doing this foam in our lab when we didn't know Taisei at all. And we filing the patent for it in 2007. Then Taisei came along later on in 2000. We met them in 2011. Yep. And then we start doing work with them in 2012. So we producing a small, we do a laboratory processing for them. We develop the process itself with Taisei, and Taisei is interesting. They send their researcher to come to be embedded in our lab as well. So the dynamic of the lab is very interesting as well, because the Taisei researchers are Japanese. So the whole lab have to speak English. Yeah, I try to force them, but sometimes they don't do English. Okay, so then we do the 10 by 10, the small laboratory production. Then we move to the company. There is another project with them in 2014 that we moved to a large mass production. And eventually in 2015, this is being mass produced in Taisei, Thailand, and being sold around the world. So this example of, this is the very first version of their data sheet for their to sell the product. But all these pictures actually being taken from our publication. So we do work for them. We can do some publication, not all of them, some of them that don't show that not too confidential. And then they use it for their data sheet as well. So this example, and this is their companies being mass produced in their companies. And the mass production part is interesting because we have to help them. The workers, unlike people in the lab, they do things that we think we never have issue before, even simple thing like weighting materials. They did something wrong in the process, so we have to prevent all these things as well. And the last thing that I would like to share is our exciting current project. So our lab being set up like in 2004, so we've been working with several things. Currently, what we do is we developing. This one is funded by Newton by Newton Fund from the UK. So we working with this project is we developing a new titanium alloy. For that will be used as implant in human. Okay, the current titanium alloy that being used around the world is actually designed for aerospace applications. So they are too strong for bone. Okay, in technical word, the current titanium 6 aluminum 4 vanadium is 110 gigapascal in young modulus, but bone is only 40 gigapascal. So what we do is we try to reduce the strength of the alloy. So this one we work with 7 partners, including MTech. So we have company called Alloy in the UK. And then we have like Oxford University and Leicester University that working with us. And we have company in Thailand and university in Thailand that working with us. Apart from design the new alloy that will have lower young modulus. Apart from doing MIM in our lab, we do injection molding in our lab. We also work with the UK that they do one of the technique for 3D printing. So 3D printing is also very interesting because you can literally just print the material that you want. You don't have to have a bulk and then machining them out. So they're saving expensive materials. They can produce personalized implant for patient as well. So this is being awarded in April. So this is an ongoing process. And sorry, the animation actually produce a noise. Okay, so this is another exciting for us. Apart from injection molding, we also do 3D printing ourselves as well. So we're developing with university in Japan that trying to do a new, is also an implant application for titanium alloy for 3D printing to saving the materials because Japan and Thailand is entering the aging society and is being funded by Japan and Thai government. So thank you very much. For to thanks all my teams as well. Thank you.
Thank you very much. This was again a mind-expanding presentation. I certainly would not have thought that titanium can be part of foams and can have so many industrial applications. A wonderful way to put into use your scientific research and indeed bridge the gap between science and industry. And I guess there's a new age for metal detectors at airports too. They have to, do they detect titanium?
Yes, they detect titanium. So if you have implant, you walk past the detector, they detect.
Yes, yes.
And the airport, they can set the sensitivity to how big the piece they will detect. Yeah.
Okay, but they have to adjust those machines to these new technologies. Amazing. Yeah. Thank you very much.
Thank you.
We are moving on now to finance and administration. Professor Yuan, China country representative and business and commercialization lead at PATH. And your presentation, Advancing Vaccines in China for the World. The floor is yours, Professor Yuan.
Hi, everyone. Thank you very much for inviting me. It's an honor for me to be here. And I've just joined this day 2. And I was amazed at the diversity of all the speakers, all the subjects they bring, and each of them fascinating.
Yeah.
So I will just share my screen and my presentation. And I'm here to talk a little bit about vaccines today. So I know in the COVID-19 pandemic, everyone knows a bit more about vaccines. And as I come from PATH, a nonprofit organization, I'm really here to talk about how some of the less compelling vaccines as business cases and how we develop them. So first, a little bit introduction of PATH. We previously were known as Program for Appropriate Technologies in Health, and was established in 1977. So more than 40 years of experience in the public health field. And we have 5 platforms: vaccines, diagnostics, drugs, devices, and health systems. And all this is to accelerate health equity. And today we are a global team of more than 1,500 people working in 70 more countries. And all those work around the 4 platforms of products, plus this health system for strengthening health systems in developing countries. But we have a very diverse team, a global team of experts. And I think for vaccine or vaccination, it really covers a lot of ground or multiple disciplines, including science, technology, engineering, and more recently about human-centered engineering, and also medical, of course, and in terms of science, the social science is also very important when we come to vaccination and introduction. We work on a lot of diseases, but these are kind of the more important ones to us. And today, my example will be about Japanese encephalitis, which is a disease that may not be very often heard of. And we also are a global lead in innovation, and talking about innovation, the journey from ideas to widespread access and impact is really what we're looking for. So we go through all these steps, and I will use my example to explain how we do these. Years ago, maybe like 10 years ago, we were sourcing innovation from around the world. At that time, a lot of innovations were from the global north to the global south. But now what we're seeing is more a pattern like this. So it's everywhere and from south to south. And we really see huge potential from emerging economics, including China. And we see 4 business cases for vaccine innovation. So COVID-19 is definitely compelling. There is a business case. It's also needed in high-income countries, and as well as low and lower middle-income countries. But there are also cases where there is uncertainty, and there is not really a very large profit margin or potential return for those vaccines when it comes to development. Companies would have to spend a lot of time and money on research and development, but it doesn't necessarily sell very well on the global market, especially when the need is largely in lower middle income countries and public market only. And that's where we have the product development partnership. And this, when we call PDP, it's a unique nonprofit business model, bringing together public, private, academic, and philanthropic sectors to develop the technologies for global health. So with PDPs, we can cover those markets in those sectors with dual market or low-income public market only. And the PDP is intended to share the risk, because there are always high risks for vaccine or drug development, and also sharing the cost. And to explain it simply, it's really to fix Jon Snow's pump. That's where the cholera outbreak in London, without the invisible hand of Adam Smith. So without this incentive from the market, but more from a manual way. And this slide is trying to show some of the cases, some of the successes that we have achieved in our 20+ years of work in vaccines. on typhoid, on Japanese encephalitis, rotavirus, HPV vaccines, meningitis, and actually one is missing here, which is the malaria vaccine. And it was recommended recently in October this year by the WHO for African countries for falciparum malaria. And these are just little vials of vaccines, but these are all unique. So this one here is a vaccine vial monitor, and this label would show if the temperature has been compromised in transportation. And we also did with BD developed auto-disabled syringes. And this is the Japanese encephalitis vaccine that we'll talk more about. Rotavirus vaccine is produced by an Indian company, and they're supplying this less than $1 dose to developing countries. This is the RTSS malaria vaccine that just got recommended. And for meningitis A, it literally wiped out all the meningitis A cases in the meningitis belt in Africa. So here is illustration of the journey of vaccine development. It's usually very long. Of course, we've seen miracles in COVID-19 vaccine development, but normally it takes 10 years or even 20 years. For the malaria vaccine, it was actually, people actually started to developing it in 1980s. And you will see here on the left, the total investment is also very high. But there are, we call valleys of death for vaccine development. The first one is from proof of concept to the phase 3 efficacy demonstration. But there is also a second valley where products are developed but not well used in large scale. And here we really need the price to be low, the quality to be high, and also in large quantity that could do the trick. And for live attenuated Japanese encephalitis vaccine, first maybe I should introduce a bit about the disease. So JE is transmitted by mosquito bites, and it has a 30% case mortality rate, and 50% of the survivors will have lifelong disability, but there is no effective therapeutics. Therefore, WHO recommended vaccination in endemic areas, which is mainly Southeastern Asia countries. And in 2013, a Japanese encephalitis vaccine developed by a Chinese manufacturer got WHO pre-qualification. And with its 5-dose presentation, the price is less than $1 a dose. And up to today, more than 550 million doses have been exported to protect the lives of children in these endemic areas. And here is the impact of Japanese encephalitis vaccines in China. And data has shown that the incidence has dropped when we introduced first inactivated JE vaccine and later with the live JE vaccine. And so this trend is very significant, and that comes to the JE vaccine program in China. First with the 2-dose schedule for this live JE vaccine, and for inactivated JE vaccine, it's a 4-dose schedule. And before 2007, 16 provinces in China had JE vaccine integrated into provincial EPI. And then later in 2008, the central government integrated this vaccine into the national EPI, except for Xinjiang, Tibet, and Qinghai provinces in which JE is not prevalent. And we do all this by partnerships, as mentioned, the PDP. And our partnership here is Chengdu Institute of Biological Products, and they are a subsidiary of Sinopharm China National Biotech Group. They were founded in the 1950s, and they really underwent a lot of renovation of their facilities. And you can see the huge change between now and 1950s. And it took us 8 years of collaboration towards this first WHO pre-qualified vaccine in China. And why so long? And here is a description of the key milestones in this collaboration project. The company also invested a lot in building new facilities. And at that time, actually the Chinese National Regulatory Authority had to pass the first WHO assessment. And that assessment was successfully passed in 2011. And that's the prerequisite for a company to be able to apply for WHO pre-qualification. So later in 2012, January 2012, the company submitted the dossier to WHO for pre-qualification. They need to submit the samples to WHO labs for testing. And they also need to have a site inspection by WHO. And so this whole process took 8 years. And in these 8 years and even beyond, PATH supported this vaccine to obtain more clinical data to generate the evidence needed for more countries to adopt this vaccine. So for these numbers, JEV1, 01, 02 to 07, we did a total of 7 clinical trials outside China to generate more clinical data to demonstrate the safety, effectiveness of this vaccine. And also the company did a lot for registration in different countries. So you can see here that more than 10 countries, this vaccine was registered, and this process still ongoing. And when we collaborated with the Chengdu Institute, we also helped them with the demand forecast for the vaccine that would help the company to better arrange their production schedules. And because our project was funded by the Gates Foundation, and it has an end date, and it is also, for us, it's very important to transfer this tool to the company itself and to build their capacity so that they could take on this work on their own. So we are, through trainings, we transferred this demand forecast tool to the company. And also it is important for a company to build a business continuity planning, and that's another effort taken on together. We can provide support on sustainability for continual improvement in their quality management system, and also in terms of pharmacovigilance to monitor vaccine safety. We help the company build their system, and they have been since being able to work on that independently. On the WHO inspection side, they also start to be self-dependent, and that's the time when PATH find it suitable to quit. So we have summarized our lessons learned into case study reports, and these are available online. And as I mentioned, it's really important for us to build this local subject matter experts in quality management, clinical development, pharmacovigilance, international registration, and business negotiation for international collaboration, and last but not least, cross-cultural communication and project management. So for us at PATH, we have a Center for Vaccine Innovation and Access, and these are the disease areas that we cover, and we cover end-to-end the whole value chain of vaccine and vaccination. And at every step, we are happy to collaborate with partners worldwide to contribute with our expertise. So to conclude, we see 4 major themes in our vaccine work. We will need to overcome biological, technical, and human-made barriers to essential medicine development and introduction. we do work on a frugal way so that we could deploy the innovations to meet the needs of low and middle income countries. And we have a line of sight to the full public value of vaccines and vaccination. And last but not least, the capacity strengthening in the countries we work in. So our work really hopes to accelerate the innovation from idea to impact. And with that, we envision a world where health is within reach for everyone. Thank you for your attention.
Thank you very much, Professor Yuan. This was it's an amazing success story, a worldwide success story. It's highly commendable. I commend you for this dedication and this global mission. It's beautiful, a wonderful success story. Also bridging science and various other fields and how science is put to use in an immediate way to help people, to help their health, and millions of people. It's amazing. I'm just awed after listening.
Thank you.
To you. Thank you. Can I ask you what PATH stands for? Sorry.
Well, we used to have a full name, a program for appropriate health. Program for appropriate technologies in health, but we no longer use that full name. So it's just PATH. Yeah, okay, please remember us by PATH.
Yes, yes. Okay. No, I think you're right for not using, using the full name, but I'm just ignorant about what it stands for. Now I know. Thank you very much. Thank you. We are moving on to a very different field now. It is ethnology or ethology, biology, animal studies. Anjali Kubini is our next speaker, who is a senior researcher at the Department of Ethnology, Eötvös Loránd University, and she will speak about canine aging from a behavioral, genetic, and neuroscientific approach. Oh, what a lovely, lovely picture, lovely image. And I think old dogs are the wisest in the world. So I'm looking forward to your talk, Dr. Kubini.
Thank you for the invitation. It is a great honor to present my work in this webinar. So I am Anjali Kubini from the Eötvös Loránd University, and my present topic, dog aging, is very interesting, I think, because there are many parallels between dogs and humans. I study dogs' behavior and cognition, and also hand-raised wolves and dog-robot interactions for almost 30 years now. 5 years ago, I could establish my own group, the Senior Family Dog Project. This is a multidisciplinary project. We study dog aging from 3 approaches with behavioral, genetic, and neuroscientific methods. Why is this research important? What could it give to the society? Firstly, dogs are very valuable members of 1/3 of the European households. Many owners consider them as family members. Moreover, in Europe, there are more dogs than children. Providing long and healthy life for dogs is important from both emotional and economical aspects. Secondly, dogs' aging seems very similar to human aging, and this animal is also unique in sharing our environment and lifestyle. In contrast to laboratory animals, it shows great genetic diversity and similar cognitive aging, including the symptoms of dementia. Aging research is a priority currently because population aging is a global challenge. By the year 2050, 22% of the population will be above 60. The number of people older than 80 will triple. 5 to 8% of old people struggles with dementia. It is more prevalent with increasing age, as you can see it on the figure. Dementia starts with memory loss and disorientation, and in its last stage, the patient is completely dependent upon caregivers. Patients are bedridden and unable to feed themselves. On average, people with dementia live between 3 and 11 years after diagnosis. So this is a huge burden on the caregivers and on the society. The most common cause of dementia is Alzheimer's disease, and it is characterized by amyloid beta plaques and tau tangles in the brain. Many species are used in aging research, but most animals do not develop dementia naturally. The gene-edited animals has low or no translational value in Alzheimer's research. The disease is influenced by many and complex factors, and because of this, the 40-year search for effective therapeutics to treat Alzheimer's disease has resulted in a clinical failure rate of 100%. Of course, there are some animal species, such as apes and dogs, which naturally develop the symptoms of dementia, but keeping them in research laboratories in large numbers is unethical, and also, actually, it's very expensive. We and more research groups propose the family dogs as a good model for human aging. In dogs, canine dementia, called canine cognitive dysfunction, can naturally develop. Dogs over the age of 15 years show at least one symptom, such as confusion in familiar places or inappropriate elimination. A lot of owners are ready to participate in research with their old dogs. But how many old dogs are available for aging research? Based on 10 studies, here I show that the median life expectancy of dogs is 13. This number actually has considerably increased in the past 30 years, as you can see it on the figure. You can also see that large dogs, such as the Great Dane, in general die younger than small-sized dogs, such as the Chihuahua. If we look at the age at death, we will see that indeed there is a peak at the age of 13. Only 0.1% of the dogs can reach the age of 22 or more. We were lucky to find 2 such dogs, both mongrels, in Hungary. Buksi died at the age of 27 and Kedves at the age of 22. Based on a human study with centenarians, we decided to identify gene variants that are unique to these dogs. We compared the whole genome sequence of these 2 dogs to 850 average individuals. We found single nucleotide polymorphism unique to these dogs. These genes participated, the genes where we found these SNPs, participated in gene regulation, immune system, nervous system. However, the 2 dogs were just enough to fine-tune the method. We need several other extremely old dogs for the final results. We have already received samples from the United States, for example. And please send me more samples if you know any very extremely old dogs. We saw that the genes influence the lifespan. And not surprisingly, in breeding, when we breed closely related individuals, can decrease the lifespan. In a recent study, 6 months difference were reported between more inbred and less inbred individuals in age at death. Interestingly, spaying is also associated with longer life, especially among females. But even more interestingly, in an experiment, it was found that 20% of lifetime food withdrawals, so when the dogs received 20% less food than the normal group, this method extended Labrador Retriever's life with almost 2 years. We also found that less inbred mixed breed dogs are more prevalent in the oldest age cohorts than purebreds. Neutered and thin dogs were also more prevalent among very old dogs. This suggests that these factors contribute to longer life. In the following minutes, I would like to talk about age-related changes in the brain and behavior. I will introduce 5 studies about age-related changes in memory, personality, dominant status, emotion processing, and brain activity. During aging, memory is the first to decline. We developed a memory test to assess this decline. In the test, we put 5 brown pots in a semicircle in the laboratory. The experimenter put a piece of food in one of the pots. The dog witnesses this baiting, but then she has to leave the room with everyone else for 30 seconds. When they return, the owner lets the dog free, so the dog can freely choose a pot. We observe whether the dog approaches the baited pot immediately or visits other pots instead. Thus, we measure whether the dog remembers after this short break, 30 seconds, where the food is. We repeat the test 5 times with each pot. What we found was that young dogs had a better memory performance in this test than old dogs. So this short test is good for assessing memory and can be used in clinical settings as well. After this memory test, we asked the owner to walk the dog in the nearby park, and we collected fecal samples from the dogs while they were walking in the park. Metabolites produced by gut-inhabiting bacteria can influence cognition. And indeed, we found that dogs with worse memory performance in the memory test had more actinobacteria in their fecal samples. Interestingly, these bacteria are in high abundance in the gut of patients with Alzheimer's disease. Personality also changes during aging. Together with the Messerli Institute in Vienna, we found uneven changes during the life course. This study was very popular in the media because the finding that novelty seeking decreases after the age of 3 years was interpreted as a canine midlife crisis by the journalists. The Times also made an infographics about the paper. We found that out of 5 personality traits, 3 changed during the life course and 2 did not. Activity independence trait decreased from puppyhood to adolescence, then decreased in a slowing rate. Novelty seeking trait did not change until middle age, then showed a linear decrease. Problem orientation trait increased strongly until middle age, then showed no marked changes. It is important to note that sociability and the tolerance of frustration do not change. So if one is lucky enough to obtain a sociable puppy, does not have to worry about the future. These findings are very similar to human personality changes. We investigated the personality with service too, because service enables us to study aggression, which is not possible in behavior tests due to health concerns and also ethical reasons. Owners reported that aggression toward animals is highest in the middle age, and aggression toward people and also fearfulness do not change through the life course of dogs. Some people live with more than one dog, and in these cases, one individual is often dominant over the other. For example, the dominant dog wins in fights or gets the food reward from the other. We found that in 60% of the cases, it was the old dog who was dominant over the young one, according to the owners. And then now I present a very interesting behavior test. It is often reported that all dogs have selective hearing. They listen to what they want to hear and nothing else. And in fact, in humans, it is well known that the processing of negative emotions deteriorate. And because of this, older people experience fewer negative emotions. Something that old people know that the end is near and they focus on positive emotions more. But others think that this positivity effect is due to brain aging. Definitely, animal models are needed to find out which theory is true. In this experiment, we played back short, neutral, positive, and negative human sounds to dogs from a loudspeaker, coughing, laughing, and crying. We measured whether the dogs turned their head toward the loudspeaker and how long it took for them to return to their original position. We found that similarly to humans, all dogs showed diminished responsiveness towards negative sounds. To the neutral and positive sounds, they react in the same way as young dogs do. The dog is the first species where this special positivity effect was found. And based on the results, we can assume that brain aging is in the background and not complex theoretical thinking about the end of life, because dogs probably do not engage in it. So far, I was talking about the behavioral phenotype, but we have also investigated how brain activity is changing during aging. We used EEG and studied sleep spindles, which are short bursts in non-REM sleep. These spindles are associated with learning and sleep stability in humans and rodents, but we knew nothing about dogs. This sleep spindle has two types, slow and fast, based on the internal frequency. Dogs during this study sleep spontaneously because there is nothing else to do in the small empty room. Their owner sits next to them. The electrodes are glued to the head with a washable adhesive. Two electrodes are investigated, the frontal and the central electrode. When we examined how the slow and fast sleep spindles' density, amplitude, and frequency change as a function of age, we found many similarities with human studies. Some associations were found only in males or in females, suggesting hormonal effects. One finding, the slow spindle frequency on the central electrode, was reported only in people with dementia. These results are again support that the dog is a good model for studying aging because the sleeping brain's activity change with age in a similar manner. We studied brain activity with fMRI too. fMRI measures brain activity by detecting changes associated with blood flow. A group of dogs were trained for lying absolutely motionless in the very loud scanner up to 8 minutes. The dogs' training took a half year, so afterwards, they participated in several experiments for years. Meanwhile, structural images about their brains are also needed. We compared these images and found that the dog's brain showed the signs of aging as the brain shrank in 4 years. But even 40% ventricular size increase in 4 years did not affect the performance in the fMRI scanner, the behavioral performance, so the dog brain can counteract these changes. We also observed the signs of brain aging during an fMRI experiment. We found that neural specificity for distinguishing words decreased with age. For these imaging studies, our colleagues needed to develop brain atlases. We also investigated how head shapes affect the brain. For example, the olfactory bulb is much smaller in brachycephalic, short-headed dogs. On the last few slides, I introduce our studies which investigated age-related molecular changes in the brain. For this aim, we have established a brain bank. We developed the unique pet dog body donation system for the owners. So far, we have collected more than 150 brains and other tissues. The samples are suitable for gene expression measurements too. Due to these samples, we could investigate for the first time whether a gene which shows age-related increased expression in humans works similarly in dogs. We found a higher number of RNA molecules in the brain, muscle, and blood samples of all dogs compared to young dogs. So this gene can be a biomarker of aging. In a cooperation, we sent samples to the University of Washington. They measured the level of amyloid beta in the brain. We asked owners to assess the cognitive dysfunction of the donated dogs. The two measures highly correlated, similarly to people living with Alzheimer's disease. So I have introduced many studies briefly, but all have a common message. Dog aging is very similar to human aging on several levels. So dogs can be good models for aging research with a translational relevance, especially considering dementia studies. And this is basically the last slide, because many of you have probably a dog at home, or you know someone with a dog. And here are my suggestions for a long and healthy canine life. So choose the breed wisely and pay attention to a healthy weight. Consider spaying. Mental stimulation and training is very, very important. And of course, the regular consultations with the vet. And in closing, as this is a Women in Science webinar, in addition to my group, I would also like to thank my family for their support. And thank you for your attention.
Thank you very much, Dr. Kubini. This was very exciting and very reassuring. I am an old dog person, so I enjoyed every second of your presentation, and I agree with everything too. One of the most beautiful things in the world, in life, is an old dog at home. Yes, absolutely, because he or she knows everything, and oh, yes. This was fascinating, especially your conclusion that studying dogs will allow us to know more about humans. You know, it's a dog-centered world that you are presenting. It's humans that will follow dogs and not the other way around, which I totally am in agreement with.
Thank you very much.
Thank you very much. Our next and final speaker is Monique Tromp, and we are moving away a little from primary science. Monique Tromp is, Professor Tromp is present now as the representative of the Young Academy of Europe, being its co-chair, she's going to speak about diversity and inclusion in a changing academic climate. Professor Tromp is a scientist in her own right, but she's speaking as an organization leader at the moment. Professor Tromp?
Yes, I'm here. I'm trying to share my screen. Yeah, I think actually my presentation would have fitted better in yesterday's session, and I was asked for yesterday's session, but unfortunately I couldn't make it. So it is a change of gear again.
No, but we appreciate you giving it today. Thank you very much.
Yeah, and maybe it's a nice introduction into the panel discussion later. So yeah, as you've mentioned, I'm here as Vice Chair of the Young Academy Europe. And in the scope of what we discussed for this workshop, I want to say something about diversity and inclusion in a changing academic climate. I think we all know it is changing and under pressure. And some of the work we as Young Academy of Europe have been involved in, but also I have been involved in personally, because as you've already showed on the previous slide, I'm involved in a lot of different boards and committees across Europe, and a lot of them are working on this diversity and inclusion, obviously, because it's still necessary, unfortunately. I guess we need to put it like that. So first, a little bit on the Young Academy of Europe for people who don't know. Young Academy Europe is a bottom initiative of young and excellent scientists. We see ourselves as you can read, as a dynamic and innovative group of young scientists who don't just do science, but also have very outspoken views about science policy and want to bring forward the policies around and touching on science. On the one hand, advising policies using scientific evidence, and on the other hand, also discussing policy concerning science. So it's both sides of that. We provide, especially, of course, feedback and advice from a young perspective, young researchers' perspective point of view. I have to say the Young Academy of Europe, it spreads from early career to mid-career researchers. So really from postdoc, 5, 6, 7 years after a PhD up to, well, almost 15 to 20 years after PhD. So we're representing quite a broad range. We want to involve top young scientists in the future European research strategy. And a way we do that is by interacting with other senior academies, but also directly interacting with the European Commission. We are with other young academies now, part of the science advice structure, science advice mechanism of the European Union. So we collaborate directly with the European Commission on that. Under SAPEA, where we try to provide scientific evidence for policies. So we respond to questions from the European Committee. But as I said, we also, the next bullet actually links to what I've just said, promote evidence-based policy. But we also want to support young scientists in Europe in their own development, think about future of disciplines, but also of science and academia as a whole, and how to further diversify and be inclusive, because it's clearly not the same across Europe still. By that, we want to create and foster a network of top young researchers across disciplines in Europe, and so interact and work together and make a bigger voice. And we seek to widen participation, as I've already alluded to. So who am I? Maybe just a short slide on who am I. You had it on as well, but I'm a full professor of materials chemistry at the University of Groningen. I worked in the Netherlands, but I also worked for several years in the United Kingdom as well as in Germany. So I've seen different situations in different countries. And my research focuses on energy materials. So we work on batteries and fuel cells. We do a lot on catalysis, and all these fields we try to develop operando, spectroscopy and characterization techniques to understand how these materials work. So it's all very related to a sustainable future. And if you think about Europe, green deals and climate action, etc. So I'm currently, and I have been for the last year, the Vice Chair of the Young Academy Europe. But as I've already said, I'm also board member of the Dutch Science Foundation, which is NWO, especially on the science division. And I'm part of the network of Dutch female professors. And what we do there is we try to promote equal representation of gender in the academia. I'm also executive board member of the Initiative for Science Europe, and I'm not sure if everyone knows this organization, but they were the ones, for example, to push for the ERCs, so for this ERC granting scheme to start. And actually, the first president of ISE is now the president of the ERC. So Maria Leptin has just taken office there. So in the executive board, and there we really push for policy for science. And as I've already alluded to, I'm also board member of this Young Academy Science Advice Structure. That is what JASAS is standing for. And there we interact within SAPEA and within the Science Advice Structure to really provide scientific evidence to the European Commission where they can base their policies on, which is a very important role where diversity is still needed in all those working groups and scientists who provide this advice. So if we talk about gender and women, and that is a little bit my focus today in the short time we have. So I think everyone knows, and I'm sure this has been said yesterday, unfortunately I haven't seen this, I wasn't there, but that there's this gender misbalance. And one of the things we do as the Dutch Female Professor Network, but also the European Commission is doing this every 2 years, I think we do it every year, is monitoring how these numbers evolve. And monitoring, we think, and I feel is very important because it gives people in management levels numbers to work with, and you can clearly see in graphs that there is a problem. So the left graph is for the Netherlands based on the numbers of last year, and the new monitor comes out next week, but I can't share those numbers yet. But you see that whereas at student level, undergraduate level, we start at this 50-50 representation, there's this clear misbalance that more men grow into higher academic position compared to women. And last year we were actually overall at a percentage of 24 women, which a lot of people think it's quite okay. But this is not equal distribution over the different disciplines, especially in science and technology. So you see this number is much, much lower. Economics, it's a very low number of women, whereas in more bio and life science, there might be more women. But there's clearly still a mismatch. But you can't look at the overall numbers, you really have to look at the different disciplines as well. The right picture is actually a picture from the European Commission, and that is the picture from 2019. So I put the links on the slides, and I think the slides will be available. They call this she figures, and I know a new report is under preparation, but I haven't been able to get hold of the latest numbers and graphs. In blue, you see the European average, which is at 33% women, and this is women again amongst researchers. So this is not split for different functions, etc. This is researchers, and this also includes researchers in industry. So this is the overall picture. I couldn't find the more split out numbers. You see actually the Netherlands is fair at the bottom here with France, and you see other countries much higher up. So in Europe, there's a large difference as well. The takeaway is, of course, not from these figures alone, but we also try to do a lot of research also within the LNVH, so this Dutch network, but also I know in the European Commission, try to do research in what is causing this, what we can do, and so to understand the reasoning behind these numbers. So there's clearly still discrimination and bias, especially bias, and that is a very cultural thing, of course, and culture and politics. I mean, some political situations in some countries do not really promote this diversity and inclusion either. So it's a combination of what we have been taught, what the culture we grow up in, and the biases we develop. And I'll come back to this in a second. There's also, which I put on between brackets, practicalities, and it sounds like a minor thing, but of course, women have children, men don't. I do see, I have to admit, in my generation, at least in the country where I live, it's much more equal balance in taking care of kids, but also elderly care. And so all of this is increasing or is improving. That's the word I'm looking for. But of course, the women are still the ones who give birth to the children. What we know also from research is that you need kind of this critical mass, and it depends a little bit on what you read. If this is 20 or 30%, I personally think it's 30%, because a lot of situations we are in this 20%, and that still doesn't help enough. That if you have 30% women in, it will initiate a cultural change and an atmosphere change, that you will grow into more women, so that it will level out more automatically. But especially the last 2 years with the pandemic, there is a lot of research that, especially where we were making progress in getting this misbalance in gender, but also in a lot of other misbalances, we were improving. The pandemic has unfortunately worsened this situation and increased this gap again. And we have contributed to a paper in Nature Careers within a European Caliper project, where we see that women are the ones who look after the kids mostly, and who take most of this care burden at home. As the Dutch female professors, we will bring out a report at the end of the month where we see similar, but not exactly the same effects. So in the Netherlands, it seems to be the case that especially men and women, so but also men who have young kids, are more affected than people without kids, obviously. But there's not a clear difference in the Netherlands between men and women. What is, however, a difference is that women are often still in more precarious positions. So men, when they get kids, they're often in these fixed permanent positions, whereas women are still, for example, in a tenure track or in a temporary position. So although maybe the effect now directly of the pandemic on their effectiveness is maybe not very different, and that they both took care of the kids, but the impact it can have on their career can be increased, of course. And we see a lot of papers that this old-fashioned role pattern is increased over the pandemic, and that is something we really need to warn for. And within ANVH and other agencies, we try to provide policy advice on that, on how to deal with it and not to lose people and especially women in the process. Again, depending on what kind of studies you read and what kind of numbers you take and how you then project this to the future, it will take between 40 and 100 years before we are at equal levels, men, women, in this, especially in academia. So that is a worry, of course. And so clearly incentives are needed. So what incentives are there? What can you do? So one of the big things is, of course, bias. And bias is not just gender bias. Bias is in all kinds of in every one of us in all kinds of areas. But if we talk about gender bias, then there's, of course, what I already mentioned, this nature, nurture, cultural thing. So how are you raised, and are there male, female professions? I mean, I put this picture on firefighters. In English, it's a neutral word, but in Dutch, for example, it is a very male word. So you don't have a lot of fire women, but you only have firemen. So it really depends again on where you grow up, how you associate with this. But what we see is that is where bias comes in. Of course, what you can do is train us, and we all need to be aware. I mean, you can't get this bias out of our brain anymore, because research also shows it's imprinted in your brain already at the age between 5 and 7 years old. So that is where you have to do something to prevent this bias. But once you have this bias, of course, what you can do is kind of bias trainings, and what everyone, I guess most of you are familiar with, to increase your awareness that at least you know you have the bias and you can act upon. But what is maybe more effective in the long run, and of course it is the long run, is to look at these kids and see how you can affect them when this bias is imprinted in their brain, so to avoid this bias. And there are a lot of different things done in different countries. And I mentioned one I know and I've been involved in. I'm sure there are many more, but this is not a comprehensive lecture, it's just to give you an idea. So we want to teach and inspire the future. So you can just go to schools, and what a lot of scientists do is go to schools, present themselves, explain what they do. But you also see that commercial companies and the campaign Like a Girl is actually from Always, and they have a whole campaign. I put the links there as well. What does it mean, like a girl, run like a girl, and run like you? And you see what the effect of this like a girl phrase, by phrase, a lot of people sometimes make, has on girls and men, and how that imprints. Another thing we do, and that's where the top picture is from, and that is something which is started in the UK, is so-called Redraw the Balance. And we have a Dutch version of that, and I know there's a French version of that as well, I think. So to go into schools at this age, 5 to 7, with female role models. And we ask kids, without having seen the role models and without them knowing that it will be all female, to draw people in different professions, and they're not very good at drawing at that age, so you describe the drawing with them. They give them names, and you see that kind of that all boys draw men, and a lot of girls draw men as well. We see now this is changing, and about a third of the girls is also drawing girls in these professions, like firefighter, like doctor, like pilot. And this brings awareness, and then the role models come in dressed up as, and if you look at this movie of the UK version where I put the link, then you hear the kids say, when these women come in, they're dressed up like. So initially the bias is already there, in that the kids can hardly believe that it's actually women in these roles. Yeah, and I go in as a scientist, and then they don't expect a white, blonde female in a dress on high heels to be a scientist, to be a professor. So this is very nice, and we get a lot of nice feedback from the kids and also from the parents. And these are things which should work, because it's really at the age where this bias is imprinted in the brain. So then, of course, there's a lot of things you can do at institutions. And I give now some examples of academia, because that's I'm most aware of, is So yeah, what can you do as an institution? So what we've seen in a lot of different places, including the Netherlands, but this is done at several places throughout Europe, is fellowships, especially for women, to attract women in certain positions, in certain disciplines, but also special tenure track positions only open for women, or preferential treatment for women with respect to jobs. So there has been an example where there's a university, and this is an example from the Netherlands, I know, where they said, well, the first 6 months, the job advert is only open for women. And if we can't find a woman for this specific position, then the job advert is also open for men. There are a lot of issues, legal issues with this. This has even gone to the Human Rights Court. And it is, you have to be very careful in doing these things. A lot of men feel that they're not treated fairly. So it brings up a lot of discussion. You have to communicate very openly, but these are measures which work. At this university, in this period where they had the preferential treatment for women with respect to jobs, they hired 50% women and 50% men. So that kind of shows that this was needed, because what would have happened if this was not the case? And even with this preferential treatment, only 50% of these new positions were filled with women. But again, if you want to do something like this in an institution, take advice from universities who've done this, because there are a lot of tips and tricks you need to be aware of to do this right, to also communicate about this openly, that you don't get too much backlash, because the discussion can become very heated, very personal, and very complex. In addition to these special treatments, special positions, special funding, of course, what you can also do, what is essential, this is not what you can also do, this is essential, to support the women once they're in, that they have proper mentoring, that there is flexibility in how they can organize their lives, especially if they have a family and other things, that you help them with childcare, but that you also mentor them in the university, within the institute, and within the country, to keep them. Because what we see with a lot of these fellowships and preferential treatments is that you get women in, but to keep them in is then the next step. And that is even more crucial, I think, and we see, because women are hired, but then if nothing is done to properly embed them in the organization, then they won't stay. So then it doesn't help. So increasing women, I went to keeping women. So how can other organizations around that help? So for example, funding agencies, which are of course in academia very important. You see special funding schemes for women. What we've also seen, and we've analyzed this a little bit, is that they are sometimes by then the institutions turned into an extra hurdle for women. So then before women get the next step in the tenure track or get this permanent position, the institution says, well, there's this funding scheme for women. If you get this, then you will get a permanent position. So in some cases, it can work against the women, and it's just another hurdle. So you have to think really carefully on how you do this, that this is not taken advantage of by institutions. And we all want to do this well, etc., and are of the intention that institutes don't do this, but they do this, and this does happen, and sometimes makes life for women even more complicated. So you need to think about this very carefully. Other things what you could do is within funding agencies, of course, research proposals are being funded or not, and so this is always tricky, which proposal is funded or not. There's a lot of discussion on how to do the assessment, how to do a fair assessment. But what we see is what we've done in the Netherlands, but also in other countries. What you can do is, when there are proposals around this cutoff for funding and not funding, those are often very equal in quality, and then you could say, well, we don't award the final bit of funding to a male but to a female researchers, and those kind of things work really well. We see important observations. These are from a research we have done internally at the Dutch Funding Agency recently, but I know this from other funding agencies as well. So we've had discussions with other funding agencies elsewhere, is that if women apply for funding and write a research proposal, they're doing equally well in getting funding. So there is a lot of research also out that if people assess funding and they see a female there, assess papers, that the female is judged less well than the male. We don't see that really at the funding agency level anymore, maybe, and maybe not in the Netherlands, but maybe this still happens. But the problem is that much less women apply. And that's, of course, also because there are much less women in the system, but also it's not pro ratio. So if you would this pro ratio of how many women are in the system and how many then apply for grants, that is not related either. So there is something to be done as well. Well, to keep women, and then I spoke about the embedding, and of course they need to get to they need to do everything they need to do. But there's a lot of debate, which we're all involved in recently, is science integrity. And this means a lot of things for a lot of different people. But to that also comes social safety. And especially in an academic system, the hierarchical system is very embedded still. There's a very dependence for the next career progression, especially if you in the lower career steps, of course. And that leads to power abuse and a lot more. So also Me Too stories and all these kind of things. So social safety is a very important aspect, especially also in academia because of the system we're in. And what has been developed there in a lot of countries is this active bystander training. And I'm not sure if people are aware with this, where there are workshops where you recognize when colleagues are treated wrong in this social safety aspect. So how you can help and how you can intervene and how you can help solve this. What has been developed in the Netherlands, which has shown to be very powerful, it just started before Corona. They've done a bit online and then now go back into face-to-face. It's kind of a theater play, which kind of brings about all these social safety aspects. So the hierarchical system, this dependence on a supervisor. There is a Me Too story that a supervisor gets a relation with the PhD, she gets pregnant, and it's very enlarged, of course, and all the issues are put in one relation, but it clearly shows the issues happening. And I've seen colleagues who didn't even think this could happen in academia, and it opened a lot of people's eyes, and it starts a discussion and it helps a discussion, and we also structure the discussion after and make sure there's help available, of course. What you see in more and more places, this independent ombudsperson, so where you can go with your problem. A lot of universities have these, but then these report directly to the college or to the management, and then they're not independent and people don't dare to go. But that's, of course, very important. And I think there is a relation with open science in that if you're in the hierarchical system where there's a lot of pressure on to publish in the best papers, where social science integrity comes into play, if there's more focus on open science, there's less of that pressure. This might also help. So I think it's all interrelated, and that's why I put this on this list here as well. And I started, of course, with the academic climate, which is changing. And I'm sure this is changing differently for people in different countries. But I think what we see in general, especially in Europe, is that there's an increased workload. Finances are under strain. The European Commission cuts funding or doesn't increase budgets. And all the issues we just discussed. So social safety, science integrity, all these kind of things. Increased diversity and inclusion, how do we get to open science? And that is a whole package which works together, where we are under the pressure, we are being judged for papers. On the one hand, we need to teach, we need to manage, we need to mentor, and not everyone is good at everything. And some routes work better for others than for others, for one than for others. How do I say this? And this is a movement which has is moving through Europe. There's a lot of discussion about this as well, which is called recognition and rewarding. And I put some links there about the initial white paper, which was written, and this was initiated from the Netherlands. But also in the Initiative for Science Europe, we speak about precarity of research careers, especially young researchers, and how this recognition and rewarding. So if we think about differently about career progression and what people should and should not do, what the different tasks are, how to value them, put everyone in their own strengths. We wrote a paper on that, which is actually taken on board by the European Commission now, and they actually changed things in the European Commission, the paperwork, the research proposal structure, etc. So if you want to look at this paper, the link is also there. And also this is a big focus of the European University Association, where there's also a link there. This is difficult. This is not an easy process. A lot of people think that's recognition and rewarding, putting context to a CV, because that is basically what you do, putting context to numbers and not just look at age factors, impact numbers. But it's not a silver bullet, of course, not for diversity. Some people think this will solve everything, but you need to do it carefully. You need to involve all partners. We need to do this internationally, because if we just do this in one country, then the mobility of scientists will decrease. Everyone needs to be trained, and we need to make sure that we don't introduce new biases, because then we're back to square one. So this is where I want to leave it. Maybe this leads to a nice discussion later. There is still a lot of discussion about this, but I think this is some of the work the Young Academy of Europe is involved in, and a lot of organizations we are working with are involved in, towards at least this gender diversity and inclusion. And thank you.
Thank you very much, Professor Trom. What a fantastic job you're doing. This was a very wide-ranging, all-encompassing presentation about your work that is well-founded and open to so many, to mending so many problems. The figures that you brought are not terribly, don't make us very optimistic, but you know, that's where we have to start from. I think your work in the Young Academy of Europe is just beautiful, just fantastic. It's a very complex project that you have brought together, and I am sure it will have long-lasting effects. Thank you very much.
Thank you. We hope so, of course.
I am sure. We are seriously running out of time, but I would like to devote a few minutes to discussion, which is always the highlight, rounding off any panel or conference. We can do several things. We can talk about the disciplinary content of the various presentations. We can talk about these, touch upon these questions that we offered for a panel discussion. And then we also need to come to an agreement about the final statement of the workshop, which has been sent out to you all, hopefully. Do we see hands raised? If anybody wants to start the conversation, would you please click on the raise hand icon so that we would see it? The first issue that we proposed was, I think, a core issue. It's a major decision that policymakers have to take and executive bodies have to take, whether to introduce quotas or to help support those social, gender, etc. groups that we want to support them at the beginning. So is it quotas or fair competition? Is it affirmative action or equal opportunity? Do we believe in equal opportunity or equality of outcome? It's a huge argument everywhere. And I would be very happy to hear arguments for and against.
I can see Professor Trump's
Trump,
raised.
yes. Yes.
Yeah, I mean, I've showed some examples, of course, on how we can, or how we've done it, or how countries have done it.
Yes.
What we've also seen, I mean, last year in the Netherlands, for example, there was a big chunk of money available from the government where people were hired. And there the panel really said you have to hire at least 33% women. Mm-hmm. So it's not a quota per se. Well, I guess that was a quota for new hires. That is a quota. Yeah. You see that there is a lot of comments and arguments in the field about this, because men feel that they are not given an opportunity, etc. But it worked really well. So yeah, I mean, personally, from a personal perspective, I've always said I don't want to be hired because I'm female. I want to be hired because I'm good. But we're not there yet, unfortunately. And apparently, I mean, some women have once told me that we need to show men that we can do it as well. I'm not sure if that's still the case, but apparently it is. So yeah, maybe in some cases it is helpful.
Mm-hmm. Absolutely. I was wondering how it applies to other identity markers, because we are talking about gender, and we are, of course, talking about binary genders. You know, when we introduce quotas for women, we base our argument in a binary understanding of gender. Anyway, it's a different issue, but how about race, ethnicity, religion, sexuality? Do we introduce quotas for all those other markers as well? Do you, by the way, do you have quotas, or, you know, whatever we call them, for other identity markers?
I mean, we don't, also because there's an issue in getting this information. So people don't want to share, or we're not allowed to use that information often. I mean, that's the case in the Netherlands and some other countries I've worked at. So that gender is the easy one, which is, well, it's not so easy anymore either, actually.
It's not that, yeah.
But that's, yeah, I don't know. This is a discussion we're also having, but I don't know. And there's as the Dutch Female Professor Network, we say there's still so much to do with respect to women, but then we're open to all women. So there's this intersectionality within that. But yeah, I don't know how to do this properly, and then what kind of quotas you add to that.
Yes, because race is also visible. You know, the usual story is that when you go home and tell your partner who you met in the street, you give gender and race. How about race? Do you have racial quotas or racial affirmative action or religious? Because I assume you have large Muslim communities in various big cities. It's just my assumption.
Yeah, I wasn't sure if you were asking me specifically. No, we don't have these quotas.
No, okay, all right. Okay, thank you very much. Professor Anjali?
Yes. I'm actually against the unequal treatment. I actually think that it has to be equal opportunities. But what we need is people have to understand that they are biased. They have to understand they are unconscious bias going on around because of the stereotype and the way we being embedded in our thinking since we were young, like Professor Trump was saying. But personally, I think if we start to say that we have to treat women differently, we have to treat different race differently, then you have also many different things you have to treat. So equal opportunity is yeah, I believe in those things. Yeah.
Okay, thank you very much. Yes. Can I ask the remaining participants then to reflect upon the final statement of the workshop, whether you accept it or not? Okay, there was one additional point that was not in the text that was circulated, and I would like to read this passage out so that when you accept the final statement, then you would accept it with this. Foster a structural change, implement impactful institutional change relating to HR management, funding, decision-making, and research programs through inclusive gender equality plans. This would come under the recommendations as point 2. Oh, thank you so much. Okay, we have it now. The GEP should be signed by the top management and disseminated within the institution. It should demonstrate a commitment to gender equality, set clear goals and detailed actions and measures to achieve them. Such plan, excuse me, must be evidence-based and founded on sex or gender disaggregated baseline data collected across all staff categories. It should consider also capacity building and training actions to develop gender competence and tackling unconscious gender bias among staff, leaders, and decision makers. A GEP should also consider measures against gender-based violence, including sexual harassment. Okay, so this was the addendum, the passage added to the original document. Does anyone have objections for including it? Because if not, then I take it that the whole document has been approved by the participants of the workshop. All right. Okay. Well, I think all that is left for me to do is close this very successful, very illuminating, very complex workshop covering both policy issues and disciplinary issues. And I want to express our deepest thanks and gratitude to our Chinese partners, to ANSO's secretariat, to ANSO's director, president, chair, for helping us co-organize this workshop with you. I am very happy with the results. These were 2 very interesting, very illuminating days. I think there's a lot we are taking away from our discussions and presentations. Thank you very much.
Thank you. Yeah. Thank you for your contributions.
Anna Maria, all right. Want to say something?
Just thank you very much for all and for the staff of ANSO and our colleagues for helping us to organize this meeting. Thanks a lot.
Yes, everywhere around the world. This was a truly international meeting, truly multi-continental meeting, and it was huge fun and very exciting. Thank you all for helping us. We have a wonderful group of people doing the burden of the tasks, taking on the burden of the tasks, and we are very grateful to them. They are very professional and a wonderful group of colleagues. Thank you very much.
Bye-bye.
Thank you. Bye-bye. Bye-bye. Thank you. Bye-bye. Bye-bye. Thanks. Wonderful.